There you
go. Okay, so here's the story. So if you look on 15, you've got Q2 experiences no net electric force. What is the charge on Q1? Okay, so let's just step back. So what's the only way that you can have no net electric force? If they're, number one, they're equal and they're opposite, right? That's the only way. So at some point, here's Q1. So let's initially say that it has a positive charge, just for the sake of argument. Okay? Let's just say that it has a positive charge. Okay? It has some positive charge, right? So if that has a positive charge, let's just say that has a positive charge, and you know there's a negative 2 nanocoulomb charge here, okay? Then if that's a positive charge here and that's a negative charge, what's that positive charge going to feel? It's going to feel. So it's going to be pulled this way, right? Got that idea? Okay. So if it's going to get pulled this way, then what has to happen from charge 2? It has to repel it, right? Okay? So it has to push it this way. So that way they cancel out. Okay? Start with this idea. One has to pull it, one has to push it. They have to go in opposite directions, but they also have to have the same magnitude, right? The value of the force has to be the same. Cool with this? Okay. Now, if you look at force, force is K Q1 Q2 over D squared. Okay? Now, let's focus on the D squared, right? So if you're going to compare these two forces, K Q1 Q2 over D squared, okay? So we're going to compare these different forces. So since we're going to set this up as a ratio, do I have to worry about the value of K? K is going to stay the same, right? Okay? Don't care about the K because we're going to set it up as a ratio. Because you're not actually asked to find the numeric values, okay? So this is more like a ratio kind of thing. But look at this. So if this force is some distance, right? 10 centimeters. But this distance is twice as much. Right. Oh, so that's twice as much. But it's going to get squared, so it's in effect a factor of 4.
Right.
Okay? So since this distance is by a factor of 4, okay? So if this is negative 2 nanocoulomb, you could let charge 1 be anything. Let's make it simple. Let's let it be 1 nanocoulomb. Because it's not asking you to find that, it's asking you to find the charge on Q2. So on 15. So charge Q2 experience no net force. Well, it doesn't make a difference. Q1, Q2, it's the same idea. Okay, it's just which one you call Q1 and which one you call Q2. So we're going to let to follow the spirit of the book. Then you're trying to find what is Q1. Okay, so let's let Q2 be 1 nanocoulomb. It's the exact same thing. Okay, but here's the main point. Since you're doubling the distance, that goes up by a factor of 4. So if that goes up by a factor of 4, then what do you know about the charge on Q1 to make the forces cancel out? It has to be 4 times greater. So the charge on Q1 has to be 4 times greater than the charge of the negative 2 nanocoulomb. So 4 times 2 gets you 8. Okay? Now, here's an interesting thing that happens. So let's look at 2 scenarios. So you have a negative 2 nanocoulomb charge here in the middle. And they call this Q2. And this is Q1. Okay? So let's say, here's an interesting idea. So you know this has to be 8 nanocoulombs. But does it make any difference in the charge? So let's say, for example, that Q1 has a positive charge of 8 nanocoulombs. Okay? So these forces have to balance each other out. So if this Q is, let's say, has a negative charge, okay? Let's just say. So if this has a negative charge, it's going to be pushed from this one, right? But then it's going to be pulled from that one, okay? And they're going to cancel each other out because it's a factor of 4. If this was positive, it would be attracted this way, but it would be pushed that way. So you get the same result regardless if Q2 is positive or negative. Okay? Doesn't make any difference. The answer is still going to be the same. It still has to be a positive value. Because why couldn't Q1 be a negative 8 nanocoulombs? Because if it was a negative 8 nanocoulombs, if this was negative, it would feel a push for both of them. If this was positive, it would be a pull from both of them. So there's no way, as long as that charge in the middle is a negative value, that charge out there to make this go to 0 has to be a positive value. And it has to be 8 times greater. Okay? That makes sense. This is why they didn't ask for that other charge, because it's going to cancel out, because it's going to set it up as a ratio, and those charges are going to cancel out. That was just a ratio of the distance. Okay? Does that make sense?
Yeah.
Okay. Let's talk about number 16. Okay? So let me kind of give you this visual on 16. Object A is going to charge 10 nanocoulombs just at the origin. Object B is placed at negative, right? X, Y, 0, 0. Okay, what's the magnitude of direction on each object? Okay. So here's the visual on number 16. So you've got, this is at the origin, okay? 10 nanocoulombs, boom, there you go, 10 nanocoulombs. That's at the point 0, 0, okay? So object B, which has been charged with negative 20 nanocoulombs, is at the XY 0 and positive 2. So it is over here. There's B. That's negative 20 nanocoulombs. Okay? So you're told that that point out there is 0 and 2 centimeters. Okay? Cool. So what it wants is that object B is, what are the magnitude and direction of the electric force on each object? Okay? What?
Shouldn't B be above A?
I'm sorry, it's 0 and 2. My bad. Because it's 0 and 2. Move that up there. Okay? Just passing through.
I'll tell you what, I just
Need to step back.
Do you teach your little sweet physics baby children? Because the ones that I have right now in Chem 2, some of them had you for physics. Do you teach your sweet little baby physics children that if the lab procedure says 7 grams, they have to sit there and get exactly 7.00 grams?
No.
Yes.
Wait.
Yes.
I remember him saying
Does
that
it
one
say
time.
7 grams
It says
or
get about.
7.00?
Even said about.
Sig
If
figs.
it says 7, then
Sig
it would be
figs.
about. If it's
No,
0.00, it's like you got it.
7.00, you still don't get exact data because that adds bias to your data. It just means you don't want 8. It means you want 7 to 2 decimals.
6, 7.
It means you're going to use a graduated cylinder and not a beaker to measure it. It means whatever you measure with has 2 decimals of precision. It does not mean get exactly 7.00 mLs. My children are in there with pipettes
Hey, they want
to make it exactly 7, and they wonder why they can't get lab done. I have never wanted to into traffic more in my life.
Now,
Dang.
that's partly on me, because if I'll tell them, if it says 7 milliliters, hey, get something close. If it says 7.00, you want it to down to a gnats.
This means use a graduated cylinder. 7 means use a beaker. This means whatever tool you use needs 2 sig figs or 2 decimals of precision.
But it means that you need to get close to 7.
Yeah, but not 7.00 to the point you are.
If I were doing this lab and that procedure said 7.00, I would get that exactly 7.00.
You should make them use density and then weigh.
Exactly. If it says 7.00.
But then you add data bias. Because now your IC 7.00 and you're going to record it as that, even if it's not. So now you've introduced bias in your data instead of recording.
But if it says, but if that's what I got, that's what I would record as 7.00.
Is this Chem 1 or Chem 2?
Chem 2.
Oh.
Did my sister do that?
Chem 2 honors. If it's Chem 1, it's not that serious.
So by introducing that bias, your data isn't.
Chem 2, that's pretty serious.
Because you're going to record the exact amount.
I think
Your
this is
math
the
should
class
be based
that's
off the exact amount. If you think you see 7.00, if you bias yourself into that, your data's not accurate.
But if you get exactly 7.00.
On accident, great. You should not spend 30 minutes trying to get exactly
What's
what.
the average rate?
It's not that hard to measure. That's a minute.
7.00 is not that big.
It's not even that hard. 2 decimals is not hard to measure out.
It's not really. Our scales. Our scales are better.
We'll agree to disagree. This is why they don't get their lab stuff.
Okay.
Yeah, they should go fast.
Okay, anyway, back to our story. You're right, this is up here, okay? Because it's the .02. Same math, it's up here. Okay? Yeah, it's just Y value. So, both of your answers on 16, okay, should start with a 4. Okay? And make sure that it says what's the magnitude and direction of the electric force on each object. Okay? So that means you should have 2 answers. A and B. Do not write down numbers and expect that I know what they are. Okay? So, on 17, small glass bead, what is the magnitude and direction of the acceleration of a proton and an electron that is 1 centimeter from the center of the bead, with 1 significant digit. Okay? So, here's your bead, right? Now, it's been charged to positive 20 nanocoulombs. So, you have an electron. What's the electron going to feel? Why? Yeah, so the electron is going to get attracted to this, the proton is going to get repelled. So, the proton, if you don't know the mass of the proton, you can look it up. Okay, it's on your equation sheet. The proton's acceleration should be something times 10 to the 14th. And the electron's acceleration should be something times 10 to the 17th.
Mr. Brigham. Yes, that's the force. And then you have to divide by the mass.
Yes.
12.
What about it?
Can you please talk about it?
Quadratic formula? That's what I did. And
Okay, before I forget, by the way, here's who I have signed up to take this class for dual credit. Well, Knox not here. Gavmai, Nathan, Popcorn, Alyssa, or not here, Olivia, and Adam. Is that it?
Wait, yeah.
I know. So, is that cool? So, if I read off your name, you're taking
What elective did you pick?
credit,
AP
right?
Physics.
Okay.
I didn't do math.
Where were you during flex?
You have your thing.
Huh? Oh, that's right.
Oh, I got that.
So I'm stuck with high get it.
All right.
I want to say.
So,
I got a tricky joke.
let's talk about
No,
number
you
12.
need business. Yeah.
So, small little b, da charged 25 nanocoulombs. Okay?
Yeah.
So, it is touched.
Ugh.
So, since it's touched, well, you're going to split,
luck
it's
on
going to
that.
take some of that charge, right?
Yeah.
So, the two beads share the 25 nanocoulomb charge, but not necessarily equal. So, what you know is that here's A, here's B. They're going to touch, not right near, touch. So you know the charge on A plus the charge on B has to add up to what?
25.
25 nanocoulombs. Okay? Right? Now, you also know that when the beads are placed 5 centimeters apart, the force between them is 5.4 times 10 to the negative 4. And what are the charges on each bead? So that's one equation. You also know that F equals K Q1 Q2 over E squared. So you know the value of the force, right? You're given that number.
Yeah.
Right?
Yeah.
You know what K is.
See.
You know the distance. So this is QA and this is QB, right? But you don't know either one of those. So right now you've got two variables with two unknowns. Little substitution maybe, right? So if I multiply this across, I get F times distance squared, right? And then I'm going to divide that by K, and that's going to be QA times QB, right? Okay, cool. Now, I would write that as QA times.
I think he's getting there. Let him cook.
Okay. So, can you get this entire number over there?
Yes.
Because you know what force is. You were given that value of force. You know what the distance is, and you know the value of K. So you can get this number. Then it's just QA times 25 minus QA. So then what are you going to do?
Quadratic formula.
Quadratic formula.
And what answers might we relatively get?
They should add up to 25.
Okay.
I remember 30
Got it with that one.
nanocoulombs and negative 5 nanocoulombs. And they added up to 25.
Negative
But
5.
I'm telling you it's not right.
Adam, no.
One answer does involve a 5.
Wait, do they both involve one?
They both involve 1.
Okay, so I solved it some other way, and I got a negative and negative for the two answers. But it adds up to negative 25, not 25. I have to, the right answer is go right.
So just make them positive.
Just make it positive.
Make them positive. Absolute value.
Hey, Bert, can I come up there for 10 seconds?
I call coming up there for
Whoa!
This is not debate, bro.
Okay, I was like, why is everyone going?
I don't know.
Go up there, Shrek.
No. That can't be an nanocoulombs because that's in coulombs.
No, so but I like it.
Yeah, then it will work. But you can't have it in nanocoulombs. You cannot leave the 25 in nanocoulombs.
I was just saying like it's not 25.
Yeah, so you're going to get something like this. You solve this thing. Okay.
This looks like a weird assignment. Not do. Wait, genuinely, after I got home, I was like, so I had.
Can we please step away from my desk?
I had no energy after that, bro.
What do I hate all of my passion?
Change. Different.
Arrows.
I can't get that right now.
Look, ready?
He doesn't want to look at your work page.
I took, the Q1 plus Q2.
Yeah.
And something that Q1 equals that minus my then I plugged it in. I got negative 10 and then
What?
Why is it
Nano.
Why is it bad?
Oh, I don't think that's right.
Why is it bad?
Which is
That is
You can't have this.
I don't care about that. It's very kind of makes it interesting.
And have this.
Makes it kind of funny.
It's
a good news
Well, I converted it. I converted it.
He gets on a lot, but he doesn't.
It's like, I'm not having an answer so astronomically wrong. I got
At least he's honest, Mr. Burkamp.
If there is
That's way different.
Make it positive. Yeah.
Maybe he falls
Maybe
asleep
messed up
listening
a
to that.
I run on those.
Like coffee or like energy drink?
What?
No, I don't.
Can
Can you prove your answers by plugging it?
I made B minus.
Like
I made
putting
B.
everything back in and finding the.
That's how I'm feeling right now because I used to.
Because it's either negative B and then the others are positive. So that
I
one.
think I'll burst some blood vessels. Oh, I got it.
So either you keep that.
How do we get numbers? No, there's no numbers.
If you're asking for help.
Yeah, it's
No numbers.
How about I won't drink from you?
He's like, don't talk to me.
Because I feel like I'm right.
okay.
Anyway,
Your answer to number 10.
that would be positive.
10.
No. It's fine.
I'm listening.
I'm also listening. I'm also listening.
I'm also listening.
My number what?
I'm not
Me.
So on 10,
What about
Okay.
10?
because if A is wrong, kind of everything is going to be wrong.
Really?
So your answer.
Really?
Bird drives the cow.
That's why he's in the back, Mr. Burkamp.
Okay, your answer to number 10 would make a really good GPA times 10 to the negative 4.
I like it.
That's a really good GPA.
I said it was really good.
Would it be
above
negative
average.
though?
We're so close.
That's my
I'm not
GPA.
sure.
Now,
No, it's not.
Should it be negative?
Burkamp, should be negative.
No, it's negative.
Oh, okay, I'm just checking.
I got
Chill.
What's your student dollar?
What is gravitation?
now, let's talk about what's happening on number 10, because you actually have to use like a net force concept.
Wait, what?
So, it's a sphere up here and a sphere up here, right? True? Okay. So, the electric force is going to try and push it away, right? But what's going to try and pull it down? Gravity. So, you have to find the net force based upon the difference between the electric force
Yeah, there's 2
and
parts
the
of it.
gravitational force. So, your answer to
Clearly not.
10B should be around 7.
Oh, what?
Let's go.
Wait, what?
Happy 7.
That was a big finger point.
Hey, now you know how I feel that one
I
day.
mean,
Wait, we
seven
add
is-
F and G.
Okay?
Now
Is that?
Your answer to 10B should be around 7.
G minus the
See what I did?
Yeah.
FG. Force of
Third law, bro.
Okay.
Same thing. No.
It's being applied
Whoa, for
downward.
which one?
And here's the electrical force that's being applied.
No, Mr. Burkamp.
We didn't do the
Burkamp-
third law,
Burkamp-
bro.
Go
to
number
number
22
right now.
Newton's third law. Forces can't be like weird.
Why? Why
I'm
do you mean
telling
electrical
you.
force?
No, it's anything.
On
I think because we were talking.
Yeah. Problem
Like, literally.
That's what I got.
Where's problem 22?
No, it's not like that.
Problem
I think he was just listening.
Where'd problem 22 come from?
That's what he got, because it's Newton's third law.
Yeah,
Forces
yours is
can't be like
problem
this.
22.
Wait, look. If you look at these, these can't happen. The forces have to be equal. It's the multitude that has to happen. That's what I just said. Yeah.
You can do it, Louis.
Unadulterated.
Shut up.
Hey, Bert, should
Zero.
So,
I don't even have a 0 in here,
look
bro.
at this.
He had it right.
I
here.
didn't see that chance, but I'm joking.
Hey, wait, so you're
No.
Oh, no.
Well, what
These don't exist. They don't exist.
Buddy, I'm trying to do my homework.
Rages because you didn't take away the first Okay?
It's honestly not bad.
Negative.
Okay? But here's the point. What's Newton's third law?
For every action, there's an equal and opposite reaction.
Oh, he right though. That don't make no sense. That don't make any sense.
There's no such thing as like this. It can never be like that or that or that. It has to be like
Had to be symmetrical.
Nathan, are you there?
No, he's in the way.
Nathan,
Do it again.
Nathan, are you?
I promise you.
Nathan, I believe you.
So, Nathan, did you hit back on me with the same force?
Technically.
Yes.
Theoretically
Hey,
speaking.
but my atoms didn't touch, so I didn't really hit you for it. I didn't hit you.
I didn't hit you either.
Okay.
You can use that in court.
Did you touch him?
Which one?
Nope. Not on an atomic level. Nope.
Oh, the very
Dang.
Can you take that out of context?
Okay.
Oh my
I expect some good B's on number 10.
What?
Si, senor.
You will be disappointed.
Oh, well, you know what? That's
Oh, Mr. Berry.
My bee looks bad,
Mr.
bro.
Berry.
It's a circle.
Number 8.
Uh-oh.
I'm a bit confused.
Oh, I'll give you.
Do I have to do 2? Do I have to make 2 tables?
Okay, we need a B.
Oh.
On problem 8, okay,
Because it's the. Oh, okay. Never mind.
you should basically have 2 sets of answers on 8.
Actually,
For 8A, you should have what's happening to A, B, and C. So on 8A, you should have the charge on A, B, and C. On 8B, you should have the charge on A, B, and C. Okay?
holy crap, bro.
So on listen to me. 8A, 3 answers. The charge on A, B, and C. On 8B, the charge on A, B, and C.
Yes.
Gosh.
8B or B and C the same charge.
You get 2 of them 0.
Yes.
Okay.
On 8B, B and C have the same charge.
I don't know the name.
Staple this to it.
I know her name.
No, you don't have to.
Yay.
Sadly.
Oh.
Who am I?
I did the last one.
It's because she's my girlfriend.
On my problem that I gave you, your acceleration on that problem should be around 30.
No, which one? 30? Which one 30? Which one? I didn't hear you, I'm sorry.
Smack him.
On the problem that I gave you,
Oh, that
Yeah.
one?
the answer to C should be around 30 meters per second squared.
Got you.
Okay?
Hey, wait, Shannon, before you run far.
So, you don't have to staple the paper to it, but if you want
On
to,
B?
that would be great.
On C, do it on C.
If you want to. That way, you have it if you want to.
I got the same thing.
How did I do?
I'll go back to it.
Wait, it's not supposed to be.
Anything else? Once, twice?
This divided by the.
So,
Should I just turn mine in, or should I actually hold it and talk to it?
Brother!
Just turn it in.
no, don't. Just hold on.
Wait, does he want the magnitude of the acceleration?
I don't think so. No, he just wants the.
So it would be negative. That's a great answer.
No, this is right. This is positive.
Why?
Because. Force divided by the mass.
Or do we turn this?
Every time.
Going in a direction. If it was negative, that means it goes backwards away.
But isn't it going away from each other?
No idea.
Ask Berg. Ask me, not Berg.
Bro.
Ask Berg, not me. Shut up, Dick. Ask Berg, not me. Shut the fuck up, you. Ask Berg, not me.
You're fine.
Okay.
He's gonna answer it like, he's gonna put it as like, wrong.
Okay.
Yeah, like
Are we
minus
good?
50.
No.
Wait, hold on. Let me staple this.
What did I do wrong on 12 feet?
Let's go. Good.
Everything.
So I did the weight times that.
Are you submitting?
Not even. I'm like halfway done. I'm mostly done actually. I'm just like looking over them.
You found the weight of the
Yeah. Dude, I thought 8 was supposed to be like 1, but I was completely wrong.
The gravitational force on the Earth by the Earth, the gravitational force by the mass. So you need to do that. You need to go F equals big G M1 M2
Because the
squared.
these don't exist because
My bad, I can't go to that.
equal opposite, right?
That's on me.
So it has to
Catch
be
the sarcasm?
so it either has to be B or C.
Oh, I might not know.
It's a bird, yeah, right?
I don't think he cares what you said.
It's a bird. Was that your new lab coat that I saw this morning? Was that your new lab coat that I saw this morning in Flex?
You got a new lab coat?
Yo, my bad. You have to go in and like over here.
It's a lab. It's like a white lab coat with the little patch on it for the solar fun patch.
Oh,
It's so cute.
yeah.
I don't realize it was a lab coat.
No,
So now.
C is right.
Yeah, why do you always sound so depressed?
1 plus negative 4.
I don't know. It's just how my voice sounds.
Okay, popcorn.
Not me.
How do you feel when Bird calls you popcorn? Do you feel like a sense of pride?
No.
You don't feel a sense of pride? You're like, he knows me for so.
Why do you have a young?
He remembers me.
How do you even get the name?
I used to eat popcorn a lot. Yeah, I eat chips.
Hey, this grade is probably.
Bags of popcorn.
Do you still do it?
Okay,
Not as
popcorn.
much because I forget.
Start that up.
It's still going.
Oh, it's still going.
Yeah.
Stop.
Yeah.
Okay. Well, stop that, just because it's going to be easier to upload.